everyone, welcome back to Style of Discovery YouTube channel. Today I would like to talk about something very interesting. So last time we discussed the electromagnetic field, and I mentioned that they are formed when electric energy couples with magnetic energy. So today I thought I should discuss magnetic energy so that we understand what those means. So let's dive in. So getting into what magnetic energy is, I want to allow us to reflect back. Have you ever interacted with a magnet before? I'm sure the answer is yes. At least growing up, I can relate to playing with a lot of magnets. I can't remember where I got them from, but you could notice their effect when you bring them close to an iron material or some metal, and you feel the force really. And then of course there's attraction. So and we had fun playing with those things. But what really is a magnetic energy? So that's what I want to talk about today. Before I proceed, if this is your first time joining us on this channel, welcome. Here we share some content about our universe, trying to understand them using scientific concepts and in a very simple way. So I would invite you to subscribe to this channel, share the video if you like it, of course like the video as well, and then hopefully you enjoy your time here. All right, so let's get into business. Magnetic energy. So we know there are different types of energy. In the world, in the universe, we have electrical energy, solar energy, heat energy, all kinds of energy. So magnetic energy is a thing, it's real. And then I would like to say that there are different ways you can generate magnetic energy, but the basic one is that movement of charged particles forms magnetic energy. Movement of charged particles forms magnetic energy. And just like every other energy, you can convert from magnetic energy to another form of energy. For example, you can convert from magnetic energy to kinetic energy. A typical experiment where you use iron filing, bring it close to a magnet, you notice some reaction. So if you sprinkle an iron filing maybe on a white sheet of paper that is on top of a bar magnet, you will notice that the iron filings will move to follow the field lines of that magnet. So this is one important experiment that helps us to experience magnetic field even when we don't see it. So one of those energy that we do not see but we experience it. So you notice that the iron filings move. Now that movement is a sign of kinetic energy, isn't it? So at that point, the magnetic energy has been converted to kinetic energy. So that's one example. Then there are other forms of energy as well, like the electrical energy. So when you are changing magnetic field you can create electric current, which is electric energy. So that's another example. There are different applications of magnetic energy, but just giving us a brief intro to what it's like. So next time when you hear about magnetic energy, now you know what it's all about. So but then there is something that characterizes this energy, because we do not see it but we experience it. And every time, I'm sure you've seen in diagrams, they try to draw magnetic field. What are those fields? So when you hear magnetic field, it's just saying the environment, the region where magnetic energy is. So wherever magnetic energy is, there will be field. So the field where it's in is having its influence. Wherever its effect is felt, that's the field. I think it's easier when we introduce the concept of field lines. because the field lines are basically the paths that the energy takes to exert its effect in the field. So those field lines help you to visualize the magnetic energy itself. So it's really a powerful energy. It has its force. It exerts a force in the field. That's why when you bring a magnet close to a magnetic material, let's say iron, we actually feel it like there is a force. You feel some sort of force. That is magnetic force. So the field lines are also very important in helping us identify the magnetic field. All right. So why should we care about magnetic field? Why is it important? I think I like to, shed light on why it's important to discuss anything, because otherwise, why should you listen to me? Why should we, spend time talking about it? But if it's not important, I won't be talking about it. Trust me. So why is it important? There are different applications of magnetic field, but the very important one is the one that connects us, and that has to do with the Earth's magnetic field. Like I will be talking later in this video, I try to classify the different magnetic fields, but the Earth's magnetic field is very powerful, and it came to be because the core of the Earth is made up of a molten iron. A molten iron is a magnetic material because of iron. So iron is a very strong magnetic material. So whichever form you find iron, it will still be magnetic, whether in a liquid form or solid form or molten form. So what we have at the core of the Earth is a molten iron, and it is highly magnetic because of its movement. So its rotation is what is producing the magnetic field. So as it's rotating in connection with the rotation of the Earth, remember the Earth is rotating, right? They form what is called a dynamo. So there is a dynamo effect when these movements are happening. So the fluid or the molten iron inside is moving, the Earth itself is moving. So this movement forms what we call a dynamo, and that's what is producing the intense magnetic field of the Earth. And like we'll be seeing shortly, this field, they can cover a large area from where they are being generated from. And that is why the Earth magnetic field covers the entire Earth from harmful radiations, harmful charged particles coming from the sun and from the rest of the universe. So this is very important because it forms a form of blanket for us, so that some bad radiations, like I mentioned when I discussed the electromagnetic field, I talked about some high energy radiations like the ultraviolet radiation, X radiation, gamma radiations that don't get in. They do not get into the Earth's atmosphere because the Earth's magnetic field already blocks them off. This is interesting, and I will be talking about this more in another video, but let's focus on why we should learn about magnetic field. So I talked about the Earth's magnetic field and its influence in our lives. There is also biological effect. Some animals, some organisms, they make use of the magnetic field to navigate, to move, to migrate. Sometimes animals move about, they move to, let's say, another region. Now, they are not able to do that for some of them without the magnetic field. So they do possess something called the magnetoreception receptor, which helps them to navigate, which is interesting, right? There is also other important, like our day-to-day life, we now have to deal with one gadget or the other. Most of these electronics, they have magnets working inside of them. In fact, this has become is now a common, tool you find in everybody's house. But it's also something to be careful about, especially if you are dealing with magnets, because bringing a strong magnet close to an electronics could wipe off everything you have inside that electronics. It could wipe off the memory. That's how strong it is. Now that could happen because there is also magnet in the electronics. So a lot of electric vehicles these days, we have generators, transformers, and even magnetic resonance imaging equipment in the hospitals. So many applications of magnets, guys. So if you are at this point still not convinced at the importance of magnets, then I don't know what to do for you. But anyways, the last and the most interesting one I like so much is the magnets in space, right? There are magnets in space. In fact, almost every object in space do have some magnetic energy. The Earth, I just talked about the Earth's magnetic field. Other planets too, like Saturn, Jupiter, those also have magnetic field just like the Earth. The stars, like our sun, has magnetic field, and they behave a little differently from the Earth, but they do have magnetic field. The galaxies, in fact, clusters of galaxies and stars are formed as a result of the magnetic field. There are primordial magnetic fields, that is very old ones that were part of the formation of the universe. They still, form some structures that we experience when we do research. But anyway, these are all different reasons why it's important to understand magnetic energy and magnetic fields, because they have become an integral part of our lives. Our day-to-day life is not complete without the magnetic field. All right. So there are, some properties of magnetic field that I think is important to highlight. I'm not exhausting them, but at least a few of them that I think we should know. I've talked about field lines, how the field lines help us to identify where there is magnetic field. And these field lines, they usually follow a pattern. So they start from the North Pole and ends in the South Pole, trying to represent the field. So it's very important that we know this. The magnetic field has two poles, the North Pole and the South Pole, and the line starts always from the north and ends in the south. So every time you see a magnetic field line, it will always have direction. Now you can't see the direction, but if you use a compass needle, it can show you the direction of the force. So that is how we know that it's emanating from the north and entering into the south, because it's a loop. It's always forming a loop. It doesn't cut out, and no matter how much it wanders, it will end up closing up that loop. That's one of the characteristics of the magnetic field. Another thing that is interesting about magnetic field is the way they do not interact. They don't jam each other. They don't, intersect. They try to mind their business. They just move in a lone path until they find their way back to the south. So from north to south, no interaction, no intersection, which is interesting. But anyways, there is also a way to measure how strong a material is magnetic, like how strong is the magnet, or how strong is the strength. We call it the strength of the magnetic field. There is a way to measure it, but even without the instrument, you can know a strong magnetic area by how much dense the field lines are. For example, in a bar magnet, the poles tend to have the more dense lines, and that is because this field strength is stronger at the poles. So you notice that the lines get compressed towards the poles, making that region, stronger in its field strength. Whereas the other area where they are well spaced out, that the field is not strong around those areas. So that's a way to measure field strength without using the actual equipment. I won't want to go into the units we use. It's usually Tesla or Gauge, but you can find these ones by yourself. But I just wanted to highlight these important ones. And we know that like poles, they do not like each other. Poles that are the same and similar, like North Pole, they will always repel. They don't like each other. But if you bring the North Pole and bring a South Pole, they will always attract. That's another important property that is good to know. Law of attraction in this case. Like poles repel and unlike poles attract. Okay. I would like to find for the last point, talking about the origin of magnetic field. Where do magnetic field come from? I've somehow talked about this at some point while talking about this, but just to make it clear. So we have natural and artificial magnetic field or energy. So the natural ones are the ones that formed by themselves. We found them here on Earth. Remember, astronomers or scientists generally, they are not creating any of these things. We mostly observe. So we observe most of the things we know today, and all the things I've been talking about, they were observed. So those natural ones, we found them here on Earth. We did not create any of them. However, with the knowledge of what we found, we can also create, and that's how a lot of the technological advancements that is happening, they all got their spin-off from one scientific research or the other. So artificial magnets, those ones were created, to simulate the natural ones. So example of natural ones, I've talked about the Earth magnetic field, the other planet magnetic field, the universe magnetic field, and all the celestial bodies that have magnetic field. All of those come under the natural magnetic field. But the artificial ones, here we have used magnetic materials to create those artificial ones, like the bar magnet. So we make the bar magnet using those magnetic materials like iron, and it is created in such a way that their poles are made to align. I will not want to get into the details, but they are made in such a way that they can form permanent magnets, really. So those are artificial magnets. There are also other ones like electromagnets. Electromagnets even creates electric current. They create electric current. So these are all artificial ones. It's good to know the difference. And I think that's a good place to wrap it up for today so that you don't get tired. And then to summarize, please take note of the key takeaways. First of all, magnetic energies are formed by the movement of charged particles. I mentioned their origin. They can be artificial or natural. I've also talked about some of their properties. They have two poles, north and south, and they do have field strength that is measurable. And lastly, we talked about their applications. So many of our electronics devices today, they use magnets. And I've also talked about how the Earth magnetic field is shielding us, just like a blanket, from harmful radiations from the sun and other cosmic objects. All right. With this, I hope you learned one or two things today. I will wrap it up for now, and feel free to ask me your questions. Use the comment section, ask me directly, and then I will try my best to respond. And share this video, and do not forget to subscribe. Please subscribe. It does not bite. And I will see you in our next one. All right. Bye.